Okay, so now let's take our discussion about these inverse trigonometric functions one step further. And let's ask the question, well, what is the meaning of these particular expressions? Because I've been seeing these all throughout the textbook, and through this particular section, what will I do with those things? Well, if we step back for a moment, remember that we had been initially putting all of our discussion in terms of the function inverse function relationship. And that's exactly what's happening right here. If you recall, we might have said that if we take a composition of a function with its inverse in terms of x, then the two functions undo each other and give us x. Now we do have to be very careful to make sure that we state that this is only for all x in the domain of our inverse. So if we keep that in mind, that's going to help us to evaluate this one. We would say that, all right, if we're given some value x, as long as the value of x, remember that the inverse sign has to be between -1 and +1, then for any value between -1 and +1, we'd say that this expression, because the two things undo each other, are equal to x. That's kind of interesting. How would we think about this? Well, let's go back to an example that we did a little bit earlier. We said let's look at this particular example in our discussion right here. We said that the inverse sine of radical 3 over 2 is equal to pi over 3. So what would that mean for me? In this case, if I were to evaluate an expression such as the sine of the inverse sine of radical 3 over 2, then what should happen? Well, by this account, we should get x. We should get radical 3 over 2, but just so that we see it, when we take the inverse sine of radical 3 over 2, we were saying that, well, this is the kind of right triangle in the plane, quadrant 1, because we're limited to angles from negative pi over 2 to positive pi over 2, that contained an angle of pi over 3 in it. So this is equivalent to taking the sine of the angle pi over 3. Well, don't forget what the sine of pi over 3 is. In the first place, it's radical 3 over 2. It's the ratio of the opposite side to the hypotenuse of the right triangle containing that angle, and therefore these two things simply undo one another. Right? Similarly, if we talk about the inverse cosine, as long as we have a value of x that is somewhere between -1 and +1, then we can take the cosine of the inverse cosine of that value of x. Now, I mean, again, I want to emphasize this particular item right here, that our values for cosine must be between -1 and +1. If we are at all asked to determine something like the cosine of the inverse cosine of 2, we'll have to take one look at that, think about our domain, and think to ourselves, no, that's not true, because x has to be between -1 and 1 for this to work. So in this case, we would have to say, well, that's just simply not defined, right? This is a value that is outside of this domain, so that doesn't work. Our y values for cosine are limited from 0 to pi, right? That's the output. But the x values that we put into that inverse cosine must be between -1 and +1. All right, how about inverse tangent? Would we have the same problem there? Well, the answer in this case is no, we won't, because x can be between -infinity and +infinity this time. This was due to the range of the original tangent function, so we could evaluate it as long as we are within the domain, right? We'd say, well, what is the tangent of the inverse tangent of, let's pick a value here. Let's say radical 3 over 3. Well, there would have to be some triangle that has a ratio of radical 3 over 3, in this case in the first quadrant, whose value, negative radical 3 over 3, would have an angle, whatever that angle is, whose tangent was equal to radical 3 over 3 in the first place. In other words, these things undo each other. So it's almost as though we could just sort of skip the middleman and say, well, yeah, look, these two undo each other. As long as x is in the domain of that original tangent function. Okay, more to come.